Good evening, ladies and gentlemen. I'm Professor Jeff Rogers, Pro-Vice-Chancellor for Enterprise and Employment here at Brunel. I'm delighted to welcome you here today for a very special evening, which is an inaugural lecture of Professor Ali Mousavi, who I've known as a friend and colleague for many years. First of all, a housekeeping note, it falls to me to do that. We're not expecting a fire alarm, so should the fire alarm sound, please leave the building and assemble in the adjacent car park. That's the one that isn't tarmacked. Our stewards, here and there, will guide you out. So Alireza, or Ali, to his friends and colleagues, graduated 30 years ago at Tehran Azad University in Industrial Engineering, Planning and Analysis of Systems, with a first-class degree, BEng. As a placement, and then post-graduation, he worked in the automotive industry management consultancy before starting his PhD at Brunel. He worked here as a research assistant before his appointment as lecturer. Over those years, he has had many diverse research and teaching activities in systems engineering, which have been most recently focused on digital transformation, smartification of industrial systems, smartification. Ali has had exceptional success in recent years in bringing in large research grant funding, a contributing factor to his well-deserved appointment as a professor at Brunel in 2022. I'm very pleased that we've been able to resume our tradition of inaugural lectures and celebrating the success of some of our most talented professors and individuals. And I hope you'll be able to join us at future events, which are displayed on the slide. Next week, Nana, Anoki, and then a second event after Easter. Following Ali's talk, Professor Steve Langdon, who's Executive Dean of the College of Design and Engineering and Physical Sciences, will facilitate the question and answers. But before that, it's my great pleasure to call on Ali to deliver his inaugural lecture on the digital transformation, me and the world around us. Ali.
Thank you very much. Very kind of you. I don't know whether this thing works or not. Oh, it does. Thank you for coming, and I hope I don't waste your time. I've promised to only talk 40 minutes, but I have a Castro-esque style. I talk for 4 hours nonstop. Some of the students there know how I do it. But it's amazing. I've never seen a photo that big of myself. Gosh, I'm so ugly. So I'm really sorry about that. It wasn't my design. So what happened to me? Well, when I started in the university, I was full of myself, and the teachers were teaching us how to learn something very specific, be proud of it, be better than your peers and your friends, be competitive, and follow a route, very, very narrow and straight. I couldn't do that because I wasn't that good. So I had to go other places. The other thing that helped me to expand or become pragmatist is that I stopped worrying about if people thought I'm stupid. So it's one thing that now I have what I call the stupidity to go into different disciplines and try to challenge with asking stupid questions. And normally when you are stupid, people are very friendly to you. So it has helped. One thing I learned from Professor Sarhadi here, he is here, he's been very kind to come today. I remember when I became his research assistant after working with Dr. Adel and under his supervision doing my PhD, I wanted I was Mansour's RA, and I wanted to desperately impress him once in a while. So I used to go in and say, Mansour, I have a great idea. And he would normally say, oh, keep it to yourself as long as you can. So it taught me a good lesson. We took it as a joke at the time. And normally I would try to convince him with my enthusiasm, please read this 7 pages of waffle. And he would read like 5, 6 lines. Says, Ali, if you cannot say something in 5, 6 sentences, don't say it at all. So it was a great, great lesson I learned. And it took me 10, 15 years probably banging my head against thick walls of funding bodies. But I think later on something clicked. And I learned to say things in 7, 8 sentences. I don't know whether it's good or not, but that's what I've tried to do. So, breaking silos, thinking and practicing. So I've done this in practice. I worked with great colleagues here and outside Brunel, trying to deal with some of the issues and challenges that we face in the modern world, and try to learn a lot from them and try to contribute to a joint ventures. So all the work that I am now claiming is mine is on the shoulders of the great, great people that I worked with, and a lot of my students, PhD students, RAs, and research fellows who have helped me to get where we are, and I'm hoping that this helps others to do the same. So, what are the main challenges? Back to my own small world of manufacturing. I see everything like a factory. I see a classroom like a factory. So, what we have to do, build machines and processes that produce no defects. We don't have anymore the money or the time or the resources to make bad products that we throw away. Build machines and processes that never suddenly fail. So, in fact, sudden failures is the most inconvenient thing that happens. When you drive your cars, if you have this planned maintenance that they call, you come for service. It's all right. You build your life around that. You manage it. You take your car to the service. But imagine your gearbox fails in the middle of the motorway. That's a sudden failure, and that's costly. Imagine in a factory this happens. In the aviation industry, an airplane on the ground costs millions of pounds. There's a project that we did with a company that produces plastic caps and plastic bottles. I remember I tried to convince this group to come and join this EU project called Zero Breakdown. And in order to convince them, I said, what happens if your machines break down in the factory? He said, oh, this is Italian. I'm sorry, I don't have an Italian accent. But he said, it's a disaster. It will cost $5 million an hour for Coca-Cola. And BMW, I shouldn't say this, I should. It costs 150,000 euros an hour of breakdown. So that's what happens when sudden breakdowns happen. We want to build plants that always work at the right capacity with the ever-changing requirements, changing material, variations in materials, variations in customer requirements and needs. Build plants that emit minimum greenhouse gas emissions. Also, Professor Katsu, who I miss dearly now, but we started working a lot. She started telling me, Ali, okay, you learn how to build things fast, quick, good quality, but what's the point if it's going to generate greenhouse gas emissions? So do something about it. Let us do something about that. So another thing is to curtail and minimize that. Also, we don't have anymore the resources. The Earth, planet Earth, has been very generous to us and allowed us to go to up to 8 billion in capacity. We are growing faster than the planet can replenish itself. So we've already blown up all the mountains that we can. We've used all the trees in the world that we can. We dug so many holes in the world. So there's nothing left. There's not going to be anything left in the near future. So we have to recycle whatever we make. Oh, they gave me one of these. Why I think systems engineering is important and systems thinking is important. From the Aristotelian times, where Aristotle started explaining how the world around us works, then the Newtonian science turned that into mathematical modeling. And later on, the engineers used that to build mechanical things. We always thought a system is a summation of its ingredients. There is a relationship between them. They are put in a specific form, and based on that, and they pursue an objective. So a bicycle, for example, may have, Damon, you know, tens or hundreds of components. But if you take one piece of that out, what is it? It's a piece of junk, right? It's nothing. It's not a bicycle anymore. The challenge to this way of thinking in engineering came through the Darwinians, the organists, not the organists, but the organists. And through Darwin, we understood the world better. There is an evolution happening. There is an adaptation process. We brought this into science and engineering, and we built adaptive systems. Adaptive systems are reactive. They first sense, they try to find out what it is, and if they are intelligent enough, they move on. If they're not, or they don't have the capacity or capability, they die. So adaptive systems also may die. So we are going into the era of viable and sustainable systems. These systems have the ability not only to utilize all those capabilities, but actively learn, so they're intelligent. They have a powerful brain. They're aggressive predictors. They invent, and they are masters of complexity. They can master complexity. Therefore, the only breeds in the world, or the only animals in the world who are capable of understanding their surrounding and influencing it and changing their environments are humans. And we are turning machines and equipment into humans. AI, you've heard about it, is misused, is abused. A lot of people are scared of it. But I think actually AI is very good because it will turn our systems that are wasteful into sustainable zero-waste systems. So now I want to superimpose that sort of evolution of systems into industrial systems. Many of you probably have heard the word Industry 4.0. That's the fourth generation of industry. And that's where we are now. So where did we start? Obviously, Industry 1.0. That's where it goes into, since the Industrial Revolution or even before that, these are job shops, highly skilled laborers who would transform raw material with their skills into end products which were very expensive. Goldsmiths, blacksmiths, and all that are in that category. The challenge to this way of thinking came by Henry Ford, the American who set up the Ford Company. So he said, this is not a way. I want to produce for masses. I want to create, I want everybody to be able to enjoy the benefits of industrialization. So what he introduced was mass production. In that era, we had standardization, machine tools, serialization of production. Now, the capability to lower the cost by lowering the skill sets and the mass production. In the mid-20th century, management science took over. So operations research, optimization processes, how you optimize processes. In the 1950s and beyond that, now we found out There's no point in having 4 big lads taking a chassis and putting on a jig and people working on it. Why not using robots, machines to do that? That repetitive, tiring, and heavy job. So the era of robotics, automation came to the fore. Science of control became the most dominant science, and there was a lot of work in that area. Then we moved to the era of Industry 4.0, which is the turn of this century and later 2010 mainly. And that is now systems are interlinked, connected. We want to, the previous ones were wasteful. So how can we improve on that? So active learning, going back to the previous one. Aggressive prediction, same processes that are coming into those. So what is making that Industry 4.0 possible is the advancement in ICT capabilities, information and communication technology, machine learning, AI, and smart systems. So, what is the modus operandi? How do we do this? So if you imagine you have a plant, in order to understand what it's doing, how it's doing it, the plant, oh, by the way, this is what I say about manufacturing. If you transform it into any other process, it's the same, whether it's a service process, banking process. This is why we can go to different places. It's the same. A lot of things are fundamentally the same. The principles are the same. It's the application. So you need to acquire the data, the information. We do this ourselves by observation. We use 5 senses. Some of you have the 6th one. So we use 5 senses to observe. From that, we do an analysis. We look into the relationship between these observations and parameters of the system. Through that, we transform that into mathematical models, because that's the only way humans can understand and transform their observations to interpretation that later on can turn into technology. So systems modeling or simulation and modeling comes to the fore. Once I build a good representative of the physical world, then the world is my oyster. That means I can do whatever I want to that computer program without disturbing the real world. So I can do predictions, I can do optimization, I can test and validate it. Some of you have heard digital twins. Digital twins are actually the brother or sister of a system, but in virtual world. A lot of us, when we were kids, we had this virtual friend or brother or sister that we played with. This is exactly the same thing. So basically, the digital twin is a representation of that physical world, but with the capabilities to sense and adapt and change itself. I'm very proud of 1 or 2 things that we've done with our group. One of them is, I don't know whether I'm proud or not, because a lot of my colleagues who are control engineers will say, what an idiot, what a bad person. I've taken maths out of control engineering because I was never good at maths. So we had to find a way of getting rid of maths there. So we came up with a solution called event tracking and genomics of industrial process. This way, we assumed if we can, anything observable in the world has an impact or effect on the current status of what we are. We are here together, and my Eastern background also helped in that way, is that everything has happened in the universe for us all to be in this room, as long as I can observe them and find the relationship between them. So what we did was that to say that let's look at all the observables, everything that we can sense, and see whether we can find the relationship between the performance or what we observe as the impact of something does with the input that it takes. We came up with something called Event Tracker. And beyond that, that was many-to-one relationship. finding the sensitivity of those elements that are impacting the system and how it behaves. We then turn that into many-to-many relationship. So now we can we basically put those different states. We look at the different states of the system, and if they repeat themselves, that means they're real. And using that, we just need to now look at which is the best or which is the optimal. It's the same way that you tune your guitar or your piano, and based on the genre that you're playing, you adjust the music and you compose your music. So this is exactly the same. So you can find the optimal performance where the system is performing optimally, zero waste, zero cost, zero greenhouse gas emission, and you adjust your strings, your controllable parameters to get to that point. This doesn't mean that we've lost our sight on the pure mathematics of it as well. We do the mathematical modeling because that is the way that we can do predictions. And we use these two together to build much more clever, or what we call much more accurate models of the system. So, in order to build something like that, and to be able to deploy it and implement it, we still have challenges. We still have things, questions that needs to be answered. You've heard the word FIFO, first in, first out. Have you heard of GIGO? Garbage in, garbage out. So basically, if you put into a system garbage, and whatever you do into it, whatever magic you want to use, at the end you get garbage out. So the information that you are collecting needs to be, or the input data that you're collecting needs to be good. So you have to make sure that that is at the right time, at the right place, with the right parameters. Then you extract the features. You find the relationship between those parameters. You find out which one is more, the output, how much is sensitive to which parameters of the system. So I think that the relationship is, what I'm trying to do is that if you want to date someone, you know, all these dating applications that you see, it exactly does that. Oh, sorry, I was in the dating application. So there are a series of data input that you want to know. First of all, you want to validate and verify whether that person is claiming that they're handsome or pretty or whatever, and they have these traits, whether they're telling you the truth. The other thing, you want to extract the features, because if you extract those features, you are able to interrelate them to one another and say, okay, this guy's good looking, or lady is good looking and rich. I don't think it's a nice personality, but because they're rich and they're handsome, I'll go for it. So you do compromisation and you do optimization. So it's that sort of thing. So sometimes you do the compromising, you do the optimizing, but you find the relationship, you find out which one is more important to you, and based on that, you take decisions. And now, to the other side is the systems modeling. Your brain exactly does that thing. And then you control and optimize. Even if you can predict how someone behaves, then you set up the environment. They call it manipulation. Is that what they call it? So you turn the environment in a way that that person can act in that way. We do it. I do it only on machines. I can't do it on per people. So, yeah. So, what are these problems? One of the problems that we have is that whether the information we're collecting is sound, is good, is valid. We have worked a lot on that. It's called signal processing, to see whether something is good or not, the information we get. Sometimes we have to fuse sensors. We have to find the relationship, so it's data fusion. Sometimes we can't put a sensor somewhere. This work we did with Evina on measuring nitrous oxide. She makes fun of me because I don't understand chemistry at all. So actually, they are much more dangerous than CO2. And apparently, wastewater treatment generates a lot of that. So if you want to put a sensor that measures nitric oxide, you have to pay about 300 to 400,000 pounds per sensor. And you can't really, no water company can afford hundreds of these around. So you have to find ways of indirectly measuring nitric oxide. So this is what we call soft sensors. So we're using other evidence to predict or project the emissions. Oh, sorry. With Professor Kalganova, Tatiana, we did some interesting projects, a very interesting project on provenance and security and quality control of microelectronics and electronics. You don't know what they can do with electronics. They can put anything into your devices that you carry, into your jacket, into your body, and they can track and trace you and see whatever. So there's no point in building a $4 billion aircraft, stealth aircraft, whilst there's a emitter saying, I'm here, I'm here, I'm here. So nowadays, that's what happens. So in order for you to make sure that the equipment that you put into a specific complex system is what it's supposed to be, and it's not doing something untoward, you have to be able to really, really assess and evaluate it. So we fused X-ray, penetrative imaging, with surface imaging to validate and verify. We did another interesting one. Sorry, I'm talking too long, so whenever you get bored, please tell me. You know, all of you have been to the airports, huh? All of you are frustrated when you go and you have to take out your laptop, you have to put it in, and then there's people saying, oh, stay behind the line and things like that. So one of the things that we wanted to do, so these are, any of you remember when we brought this big airport scanner machine here? Oh gosh, what a challenge it was to bring that thing here. And some of you got free coffees from me. Some of you did, I'm pretty sure, to come and give your laptops to us. So the idea was that to automate the inspection of whether there's any hidden explosives or triggers of bombs in laptops. We built the solution. Out of that, we got a patent on entropic gray imaging, and we successfully managed, with very high accuracy, to detect any untoward device, any tampered device. I did a computer simulation on the 21 largest airports in the world. We could save 400 million man-hours or person-hours if this solution is replaced with manual inspections that is currently being done. The sensor, if you've seen, there are people, there's the inspection guy who looks at these and decides whether it goes or not. So there's another thing, another time I will tell you that how difficult it is, even if you think you've cracked a very big industrial problem, it's impossible. It's very difficult to sell it to the industry because they don't want it from you as an academic. So that's some of the work that we have done in these areas. We worked on electronics, on inspections, done a very interesting project recently on autonomous vehicles. Still, I think it is going to be something which is totally different from the current deep neural networks applications that are being used. So hopefully we'll try to test it somewhere. We also work a lot on structure integrity and basically smart skins for composites and aircraft structures. Also, in addition to hardware analysis that we do soft optimizations as well, from scheduling problems to estimate the remaining useful life, emissions, energy efficiency, and so on and so forth. So that's what we do with factories. We take information from multiple sources, call it plurality, and turn it into singularity. In that sense, we take all the information that comes from multiple sources of sensors and actuations. We transform that information into key performance indicators: quality, productivity, energy, environmental impact, inventory management. These are transformed functions. These are where your models, mathematical models, merge with your sensors. And from there, that's still, you're saying quality, productivity, energy. This is apples, pears, and oranges. A lot of people have that in the factories or in anything that they do. But the problem is that they cannot put them together and make integrated decisions. Because if you want to improve productivity, that means speeding up your line, you have to compromise on your quality. So which one do you compromise? So we have translated those into cost functions. So you can now say, if I take a decision, this is the cost of that decision. If I put more emphasis on a specific part, then this is going to be. So all that information, apples and pears and oranges, have turned into a uniform metric. That enables you to make easier decisions, and you can involve everybody, from the accountant in your factory all the way to the engineer who is dealing with machines. Some of the work related to this area, this is resource utilization. It means how much your machine is being used or your resource is being used. And you can find where the minimum cost is. In this specific case, it's just over 70%. So there are two types of processes that we look into: continuous and discrete. Discrete means the elements within that system are discrete. You can put a border and boundary between the physical border and boundary. You're making bottles of wine. It's a bottle and a bottle, another bottle. This is discrete. If you are talking about continuous, that means it's moving, it's flowing. So gas, liquid, any type of liquid, oil, water. So this is the work, one of the work that we've done with wastewater treatments, a number of projects that have gone into building the necessary monitoring and control tools to optimize the performance of water and wastewater treatment. 6% of Europe's energy is consumed on treating water. So if you can reduce that by any amount, you're creating a lot of profit for companies and also reducing greenhouse gas emissions. So that's a lot of work that we're doing continuously, and we're developing solutions in this area. Processes and machines that never break down. That picture you see, it used to be a video. I don't know what happened to it. That's 270 caps. I made a mistake. So 270 caps, plastic caps, are made per minute by a machine. What that means, this machine melts plastic, molds it into a die, creates the cap, cools it, and spits it out. You can't see how fast it does this. This machine has 170 sensors monitoring every single component in that system. This is a machine that if it fails, Coca-Cola has to stop. Bayer or any other GlaxoSmithKline's pharmaceutical lines will stop. So the challenge here is to find the remaining useful life of this machine. Traditionally, what we did, what was maintenance people's job, was that they take historical data about frequency of breakdowns, They did a statistical analysis, they did a curve and said, we think that this thing is going to break, but this was a normalized system for all the machines in the world that they sent. This is not good enough, because a machine that works in Malaysia is very different with a machine that works in Germany, because of the material that it's using, because the way it's in the environment that it is, the way it's maintained, and so on and so forth. So basically, we have to build maintenance plans for individual machines. And we did this by looking into a myriad of information that the machine has. And component by component, we took 5 major components of the machine, and we created a digital twin. And based on the material that goes in and the state of the machine, we can predict near exact when a product fails. A machine fails. Why do you do this? So if you look at these silly lines that I've put in those black boxes, those black boxes are your planned maintenance. So you're planning your maintenance in a specific period. Now, if I am observing this machine, and if I hit those black boxes, my prediction of remaining useful life of a component of a machine or a process hits those, I'm okay. But the problem is that most of the time it doesn't. So my prediction could be that red line, bang in the middle of 2 planned maintenance. So what is the strategy? What do I do as a line manager? I have to make a decision. Do I do a preventive maintenance in time RT minus 1? Do I do it there? That's preventive maintenance. Or I wait until it fails, but because I know I'm prepared for it, I can quickly fix it. At least I'm prepared. Or I change the settings of the machine to allow it to run for a longer period. These are all risks. These are all associated with cost of production. I, as a line manager, as a production manager, have to make these decisions day in, day out, 10 times a day. So if I build something that they can make that decision to see those costs, they can make those decisions better and more effectively. So we have done this in several projects and several demonstrations, and we're trying to now scale these activities up to really, really transfer it to the industry and the benefits to be reaped out of it. So what is the future? What do we have to do? We have to improve on sensor technology and data acquisition science. We have to build new methods and techniques for better automation and smartification. Embedding intelligence into machine tools and robots. AI's real activity is there. It's not the chat GPT. It's very nice, but I don't like it. It's terrible. That's not where we want AI to go. And we shouldn't allow it to go there. I'm sorry, probably someone's recording it. I'll be banned from Google. I want to sell something to Google now. Anyways, I think the future, the classes are going to not be the upper class, the middle class, the lower class. That came traditionally from your lineage, your DNA, your genealogy, and the amount of wealth you had. The future is about people who think or have the capability to think, and the others who do not want to think, and they're suppressed not to think anymore because others will think for them. And that new class is going to be much smaller than the current upper class, lower class, and middle class and lower class. So the only advice I can say in the new era, try to be in the upper layer, because the bottom layer is not going to be very nice. So we want to evolve things to create zero-waste society. This core can be replicated everywhere and anywhere. Okay, I'm talking too long now, so I promise 1 or 2 more minutes. So where have we been? We've been from sewer to space. A friend of ours, Payman, you know, he hates this. He told me, "What do you mean, you're jack of all trades?" I said, "Yes, let me be the jack of all trades. I want to poke my nose. I want to be idiot and all those." But in reality, we work with wastewater treatment plants. We really look into poop. And all the way we are building structures that go to space and act and react under stress and strains in space. And I'm very proud of it. And all the things in between. So, an advertisement. We have a Brunel Center for Digital Manufacturing. Hopefully in my lifetime, our lab will become ready. But once the lab becomes ready, I'm hoping that this is going to be a showcase to show a very flexible environment where we can test and evaluate advanced technologies and demonstrate it to stakeholders. The objective of this center, and I want my colleagues to advise their colleagues who are not here, to come and talk to me about it and to join. It's not me, this is Brunel Center, so it's your center and their center. It's just, I'm just there because nobody else wanted it, probably. But we want to create the scientific and technological infrastructure for lateral and systemic thinking and uplifting of the future industries. BMW is investing 2 billion euros on Industry 4.0 compliance. In 2026, there will be Industry 4 compliance, all the plants around the world. I had a chance to talk, to little understand the Kingdom of Saudi Arabia's ambitions. They are going to invest $20 billion, if I'm not mistaken, to get by 2030 that all their industries are conforming to Industry 4.0. Germany is on its way. I hope we can do the same thing in the UK. So, that's our center. Please come and join us. And some of you are members, but we're going to become much more active when the platform becomes ready. In 2020, this is the last, I promise, last slide. In 2020, I went and visited the mini plant in Oxford. I was privileged because it was a time that nobody else was allowed, so they gave me a full spiel down there. It was fascinating, and they explained about their problems, and I explained about my problems to them. None of us could help each other at that time. But anyways, the interesting thing that caught my eye was this poster. What is the message of this poster? Look at the competition. Do you remember the silo thinking I was telling you? So they say their current competitors, well, actually they're quite arrogant because they think only Mercedes and Tesla is their competitor, so Jaguar is not their competitor. They think they're superior. But interestingly, that's the old age. Our competitors are were Mercedes and Tesla. But our new competitors are Amazons of this world, Apples of this world, Dysons of this world, Googles of this world. That's Mini for you. That's BMW for you. Well, I think that's it. Yeah, that's a little bit of self-promotion. If you like to see any of these papers, they're all now, what do they call them? Golden free access. So you don't need to pay for it. You can just give me a £10. I'll give you a copy of it. Thank you very much.
Thank you, Ali, for a really fascinating talk. So when I became interim executive dean of the college about 12 months ago, I didn't really know Ali terribly well. And I was told that he was a professor of manufacturing. And in my mind, I thought, well, that seems quite narrow. I thought, I'm sure he's a nice chap, but, you know. And then I've had the opportunity in recent months to talk to Ali a little bit more about his vision and his ideas and some flavour of what he's talked about today. And it's clear to me that I think, I mean, I don't want to put words in your mouth. I think Ali is interested in manufacturing, but I think primarily Ali's interested in solving problems and understanding how to fix things and how to make things better. And in doing that, and I think you've really brought this across today, I think as an institution that seeks to be multidisciplinary in its outlook, I think we have an individual who is incredibly multidisciplinary in the way he approaches problems. And I can imagine a future in a short while where you're working potentially with colleagues from all the different departments in the college. I think, you know, mechanical engineering, mathematics, computer science, electrical engineering, I think such broad interest, and it's really fascinating. And I think we should treasure such individuals, and I think I've really enjoyed listening to your talk today, and I hope the audience have too. So we've got the opportunity now for some questions, and I think we have a microphone at the back there. So has anybody got any points they'd like to begin with? So I think at the back there, and then.
Hello. Yeah, thanks, Ali. Thanks for your informative session. Basically, myself is Nagesh, and I have a very fundamental question. Maybe it is very simple question for many of the people, but myself, it's a very tough doubt since been years. Coming to the slide number 8, I think I do remember. Since I've been in digital transformation and infrastructure transformation for many years, it could be 8, slide number 8. Okay. Yeah. Yeah, it's giving like a lot of information since ages. But my basic doubt is, what could be the objective of any innovation while at the origin? While process of transformation, it could be anything. It could be reach the goal, or it could be misleaded to some other way. But at the starting position, any innovator thinks the purpose of any innovation or transformation, what it could be, what they think. Because if you go from ages like not only 19th century, since 10th century, 11th century, revolution is taken place towards different ways, like technology, electronics, electrical, so many ways. Every time, issues been increased, never been reduced. Suppose we are in 2024, we are aiming for something. We feel like this new, whether it could be AI or something, may solve many of our current issues, but it's going to bring new issues. It would be more complex than the current lifestyle. How we can see all these things? Because any innovator, while inventing something, what could be their objective? What they think? It should help people, or it should make more money, or it should increase the global utilization. I have a fundamental question about this. I think this is not a wrong question.
Yeah. I hope I understood your question. The point is that what we have done before, we gazed in the skies with our bare eyes. So we looked and we could interpret it as much as we saw. As the technology has improved, we got telescopes, now we can see to the edge of the universe. So what the technology has enabled us, as you say, we see wider, we see deeper, we understand. So in addition that we add to the complexity, but we understand more. We have now capabilities, the scientific capability to interpret those phenomena. Also, we are finding better objectives beyond the objective of reducing cost, generating wealth. and creating comfort for the people. We have now come up with other problems because we think we have reached those, and has created all this wonderful growth in population. But that population now adds to your environmental impact. So these are coming in. You're never born an innovator. You're faced with a problem, and you sit down, bang your head against the wall to find the solution for it. And a few of us, or a few of others who are much smarter, go and try to solve those problems. So I love these challenges. That's actually, the bigger it comes, the wider it comes, the better it is to solve.
Yes, thank you. And even I too love the challenges. But while analyze myself, why I'm taking that challenge, always I have doubt where it leads to. What the final objective of achievement?
Well, I don't know. It depends if you are a religious person, is to get closer to God. If you are trying to help your fellow citizens or fellow human beings, you try to solve their problems. You if there is contaminated water, you try to go and solve that to create clean water for them to drink. Agriculture, production, and so on and so forth. So those are your challenges, and that's where you want to concentrate your efforts in.
Yeah, thank you. Actually, Industry 4.0, most of the technologies I've been working for the last 10 years.
Fantastic.
Big data, continuous optimization, aggressive prediction. Yeah, while starting off working of that, I see a lot of potentiality. While in the process, I identified more issues than advantages. I don't know where it leads to, but thanks for your answers.
Thank you. Okay, I think in the middle.
Hi. Thank you very much, Ali. I really enjoyed that so much. I'm not, I'm not the person who is into the sciences. I'm more an art sort of person. But, I came to open my brain, really, let something in. But Industry 4, absolutely fascinating. I just didn't know it existed, totally new for me. The question it brought up for me was, are we going to be producing more goods that last for a very long time? And I just thought about the bottle mentality we have, buy one, get one free, how's that? It just seems there's a bit of a clash.
This is where the multidisciplinarity comes in. Fundamentally, our finance systems, our understanding of growth, economics. I mean, the next challenge for me is to go head-to-head with the economists, actually. That's where we're going. So the models are wrong. The models are promoting consumerism. The way the way wealth is described in economy and in finance is flawed. So it has always been. This was the same thing when I was 30 years ago now. Gosh, it's a long time ago. 30 years ago, when I went to engineering school, my job was that's what they told me, that there's an infinite amount of raw material at your disposal. Don't worry about anything upstream. Your job is to make this as quick as possible, as cheap as possible, and with the quality that is expected. That was my job. The whole industry, from Industry 1 to still now, is built on that philosophy. So now the challenge is that no, we're damaging the world too much. We have to recycle. We have to build for recycling. We have to design for recycling. So we have to change fundamentally. And that's why, as you say, as the problems become better when we see better, we can change our attitude. So there's a lot to do.
That's hard. Small bit on Sunday, I went to a shop in Ketchtown to buy something for the house. And the guy said, "Oh, would you like a plastic bag?" I said,
You're absolutely right. I hope, they told me don't talk about politics, that a friend of mine told outside. Let's hope Donald Trump doesn't become US president again. But the point is that we should vote whether we should vote for a US presidential as well. But yes, you're absolutely right. But it's changing. Maybe that nowadays I see with my own children, I see a lot of behavior. It's changing.
Great, thank you. I think we've got a question over here.
Hi, Ali. Thank you for the nice talk. I saw the announcement on the website today about your talk, and there was a topic under your thing is like a smart cities.
Mm-hmm.
I just want to know, where have you worked anything on smart cities, or are you interested?
Yes, some of the work that we have done on smart cities is sensing and again, emissions, traffic optimization, landscaping. Actually, we were in a large group of smart cities in Europe with Ivina. So we're doing a lot of work in that area as well. Reduction, smart cities is smart factories, smart agriculture, smart traffic system. That's why it's all interrelated. So the future, I mean, autonomous vehicles that are going to be introduced, yes. So
I'm quite interested. I'll get in touch with you.
Great, thank you. Jeff.
So Ali, I saw somebody give a talk the other week, and they were saying that net zero was going to be the 5th industrial revolution, and that, you know, the only difference between that and the previous 4 was that there was a stopwatch, because we need to get on with it, otherwise there won't be a civilization. So do you think Industry 4.0 contains most of the ideas that is going to get us to grips with net zero, if we ever do get to grips with it?
absolutely, because if we start understanding what the state of affairs and the processes, all these processes that we're involved in, what they do, what their real impact and the real performance is, then we can come up with solutions to contain and control the damaging part of it. So one of the things I think we have done, which is very unique, very new, a lot of those factory performance monitors and analysis and control is there. You know, you want to improve quality, you want to improve. We have started using the CO2 emission as a parameter of control. So it becomes embedded in that decision and optimization. So that will change things. And I think net zero is that we want to go to zero waste, zero everything. So if we increase circularity index, if we increase or reduce the usage of energy, fossil fuel especially, or replace fossil fuel, all these are going to help in that net zero.
Great, thanks, Tatiana.
You just, Jeff, got my question, but I wanted to paraphrase a little bit because you just give idea to Ali what will be Industry 5. But this is what somebody else is thinking. You've been in Industry 4 for a while. Yeah. You just told us that Dubai is going to implement everything in Industry 4. It means industry is already adapted all this, like sort of companies are getting in. So Industry 5, what in your opinion it will be? Not about what the government think, what about anything else? What will be revolutionary that will change the world in Industry 5, in your opinion?
You always ask difficult questions.
I'm
it's
sorry.
Not fair. Frankly, we're still struggling with Industry 4.0's implementation.
It's okay, but industries adapt this.
But hopefully in Industry 5.0, first of all, we learn more of what we're doing like. So I think that evolution is going to be more of introduction of arts, social sciences, finance and commerce in the right way.
So manufacturing is dying, finances
No,
are winning.
manufacturing will never die because we still have to produce things. Manufacturing is going to become more genteel in its way. So it will become less polluting, more atone to the environment that it's functioning. So it will not create more damages to the soil, to the air. And hopefully, I don't know, I mean, I haven't got that far yet, what Industry 5.0 is going to be, but let's see what the impact of Industry 4.0 is first. And hopefully in 5-6 years' time, you and I will sit and say, let's write a white paper for EU, or not EU, sorry, UK, and America, and Australia, and India, and China, an Industry 5.0 white paper.
By the way, fascinating talk and incredible lifetime achievements that you have covered. It's impressive.
Thank you.
Truly.
Great. I think in the middle here.
Hello, Ali. Thank you very much for a lovely, fascinating lecture. Question for you. I think it's going along what our colleague was asking earlier. It's about where we're going with Industry 4. I think evolution of manufacturing as a service, manufacturing as a cloud, that's pointing the direction to localization, to coming away from globalization, which is in line with, reduction of carbon footprint. Question for you, in terms of genetic algorithms and event tracking that you outlined, can't you take the next step and forecast what 5 is going to be based on your models, or is that an impossible task?
I said I try to solve some problems. I cannot solve all. I don't know. I mean, it's because we are now trying to turn machines very close to humans. So a human who is aware of his surrounding, it takes care of his surrounding, and hopefully it will influence his surrounding for betterment and sustainability. That intelligent industry, with the help of humans who are going to carry on thinking rather than allowing other things to think for them, is going to generate a new mutation. I seriously haven't ever thought beyond that, because I think the next evolution, the next mutation is going to be, how do we minimize or maximize the cycle and the recycle for infinite life of material, copper, titanium, etc., etc. How do we build supply chains or chains of things that these systems never go outside the chain, so we don't need to damage the environment, go further beyond. But it's very fascinating. Thank you very much. I have another problem to solve now.
Okay, I think we've just got time for a couple more questions. I think Savas first and then Chapan there.
Hi, I'm,
okay, the other way around.
I'm not a scientist. I'm a social scientist. What I study is consumption, yeah, and when it comes to economics and resources, we tend to want to make stuff for more consumption. However, we do understand in economics that resources are limited. So therefore, the less we have, the more consumption the less we should consume. However, if you think about how economies make goods for mass production in terms of one type of consumption. However, on the digital platform, we are all consuming different things now. So if I want to market to every one of you here, I can almost personalize it. Like, for example, the phone. The phone is the same. We choose to make it different, yeah? However, what I would say here is that there will be more human-machine interactions that will change the consumption. So I suppose my question to you here is, what do you think the future of consumption is going to be like, given the way you think in terms of processes, yeah? The way you say that economic models, sorry, you didn't say that. You said financial models are flawed. So we have introduced blockchain, which means transparency is definitely there. So, but how do we, in your world, because I'm trying to understand your world versus my world in terms of consumption. Is the question clear?
Yes, it's an interesting one because the point is that because the models of wealth, definition of wealth and wealth generation and status in the society is based on consumerism, encouragement of consumerism. I think this is going to change because now we're becoming much more aware of our environment. Actually, Dr. Gafurian at the back, we are now looking into challenging the current way of thinking of economists. The point is that unless we do not calculate the impact of damage to the environment by machines and equipment now and turn it into a monetary, do you remember that cost function that we did? Turning that into a monetary value that everybody could understand. The example of the plastic bag here. Maybe that person wouldn't understand this plastic bag is bad for the environment, but they will understand that that will create 30 pounds of loss to you and me and everybody else. Also, the biggest challenge we have, we are generating, especially in manufacturing and in water treatment and environmental friendly solutions. There are new technologies that are coming, which are using less energy. They are much better in recycling. They're better in all the way of performance, but environmentally. It is very difficult to convince investors to invest in these technologies. They all come to the level of TRL, what we call it, TRL 6, 7, and they hit a brick wall because none of these existing financial models allows you to measure the impact of this in the right way. So the rate of return and the payback period of these new technologies show much longer payback period than the existing technologies, because this existing technology model is built on that. So what we have to do is to show that, no, it doesn't take 25 years if you use this water treatment technology. It's not 25 years, the rate of return. It's 5 years, because in that 20 years, you will gain environmental gains, which is not monetized yet, or properly monetized. This is where we're going. This is maybe the industry for 5.
So you get an answer.
Yeah, I think maybe the industry 4.5, and then they don't 5. But I don't know whether I answered your question.
I think you have, to some extent, and I do agree with you with regards to financial modeling, but I think when it comes to stakeholders, and especially shareholders, actually, the rate of return is very important.
Yeah.
I mean, and that's unfortunately how the world works.
Yeah.
Sorry, one more question. What is your concept of AI? Because misinformation or disinformation on AI is quite rife at the moment. Yeah, I think is it being recorded?
No. Is it being recorded?
It's probably going to be.
I'll take all the responsibilities.
Yeah. So, what is your opinion on AI and misinformation? Because can AI detect misinformation? Because a lot of consumption today is about whether we believe what we read.
You see the misinformation. We get misinformation even by our sight. You make mistakes when you see something. So is that misinformation? Is someone lying to you? Or your technology or your capabilities is limited to understand and appreciate that phenomena that you're observing. So to me, yes, if we create a society of the thinkers and non-thinkers, it can be abused. It can be abused because they will take the power of thinking from people. But on the technology side, I think no, because we are building now solutions, something called intelligent, for example, data acquisition, in which you're trying to validate that sensor. But it's technology. What is observed by a sensor, by a camera, Either you take it as reality or not is up to you. I don't want that to be done by a machine for me. I will only use AI to do the repetitive and boring jobs that humans don't do. I don't want to replace humans thinking. Anybody who is saying this or claiming that they're doing such a thing or wanting to do such a thing, they want that power to control. And we have to resist that. I will resist that. I'm pretty sure Tatiana will resist that. So the point is that no. AI is only to make our life better, to understand the phenomena better, to optimize and improve what we want at the performance. A lot of it to help us to reduce the damage that we're making to ourselves, both psychologically, emotionally, and also physically.
Okay, great. I think we've just got time for one final question. Savas.
Okay. Ali, thanks very much for the presentation. Very, very interesting. And I was drawn really to the discussion about Industry 3, or Industry 4 and Industry 5. I mean, the question I have really, if I wanted to be a bit cynical really, what are the differences? And is there much difference from, was there an Industry 3 or Industry 2?
Yes, because the reason for it is that, first of all, our domain of parameters that we are now sensing and achieving or caring for has expanded. Before, you and I probably, you were an expert in refrigerations, and environment was always part of your category. But for me, it wasn't. I never thought about it in my own problems. It's new to me. So the breadth, we have opened up a little bit more. That's one thing. The other is that the capabilities of sensing, the price of putting technology to collect information is becoming much more affordable. And the advances in mathematics, advances in what we call computer science, has now enabled us to do things much more effectively and much more accurately. I think that's the change, because in Industry 3, we still did repetitive jobs. We were not expecting for autonomy that we are now expecting for Industry 4.0. I want to be able to create an autonomous factory that works in its maximum capacity or its best capacity.
But then how do you do with the people really that are made redundant, for example? And it's the same, and if you talk about really the issues we have, for example, with the food sort of side. I mean, you say that really you want to manufacture locally, and I think somebody sort of earlier said, okay, you manufacture locally for the local use. But what about people in Africa? What about people in...
You're absolutely right.
Yeah, so I think there's a lot of philosophical questions.
Oh, yeah. I mean, we can sit down and philosophize. Yeah. You're Greek, I'm Persian. We can go all night long. But in reality, this is not about. This is where the duty goes into the education system. We have to now change our education. So as this has happened, we went from the blacksmith to big press machines that can do much bigger, much faster, its effectiveness. But then that blacksmith becomes machine operator. Now, a lot of that automation that we're doing, a lot of paperwork that we're still doing, can be done by machine. Now, it frees those people, better education, to do something beyond that. That mutation to Industry 4.5 or whatever it is needs a new breed of education. So it goes back to education, I think. I think we have to go up somehow.
Okay.
Yep. But let's talk about this over time.
Okay, thank you, Ali. And that's an excellent point at the end.